Welcome to our video. Our title for the instrumentation project is Optimizing Solar Energy with Angular Displacement Measurement. Today we will be discussing about the crucial role of angular displacement measurement in optimizing the performance and efficiency of solar panel. First of all, we look at the introduction to angular displacement measurement. Angular displacement measurement is essential for precise positioning of solar panels to maximize their exposure to sunlight throughout the day. The efficiency of solar panels heavily depends on the angle at which sunlight strikes their surface. Let's look at the type of the transducers that we use to do research before we choose the suitable for our project. First, let's look at the resistive transducers. This device converts physical quantities like displacement, force, pressure, or temperature into change in electrical resistance. Common types include strain gaugers, thermistors, and potentiometers. They are widely used to their simplicity, cost effectiveness, and versatility in measuring various physical parameters. Next, we have analog transducers. These convert physical quantities into continuous proportional electric signal, usually in the form of voltage or current. Unlike digital transducers, analog transducers provide a smooth and continuous output, making them ideal for applications requiring precise and dynamic measurements. Now let's discuss about passive transducers. These generate electrical signals in response to external excitation without needing an external power source. They modify an external electrical signal due to a physical stimulus like a change in resistance, capacitance, or inductance. Common examples include thermistors and strain gaugers. They are valued for their simplicity, reliability, and lack of complex power requirement. The next is potentiometers. Potentiometers are a specific type of resistive transducers used to measure displacement or position. They work by varying resistance along a sliding or rotating contact. This resistance change is proportional to the wiper's position, allowing precise measurement of linear or angular displacement. Potentiometers are commonly used in volume controls, position sensors, and joystick due to their simplicity and reliability. And lastly is optical rotary encoders. Optical rotary encoders are transducers that convert rotational position or motion into an electrical signal using optical sensing. They consist of a rotating disc with encoded markings and a stationary optical sensor. The encoder generates pulses that correspond to the shaft's position or movement, providing high resolution and accurate measurements. They are widely used in industrial automation, robotics, and precision motion control systems.
Good morning, everybody. The type of transducer selected is the optical rotary encoder. This type of encoder provides high resolution, accuracy, and reliability, which are essential for the precise control of the solar panel's orientation. Next is the key specifications of optical rotary encoder. First is the resolution. The resolution is up to 5,000 pulses per revolution (ppr). The accuracy is around plus minus 0.01 degrees, which is very accurate. The sensitivity is very high. It is capable of detecting minute changes in angle. The drift is very minimal, as optical encoders have low temperature drift compared to other types. The maximum rotational speed of this transducer is 30,000 rpm. The operating temperature range is around -40 degrees to 100 degrees Celsius. The supply voltage is around 5 volt DC. The current consumption is around 30 mA typical. The interface is incremental, can be easily interfaced with microcontrollers or other digital systems.
Greetings everyone, my name is Balahariharran, matrix number 2210188. Here I am to explain you about characteristics of optical rotary encoder. First, it is high resolution and accuracy. Optical encoders use light sources and photodetectors to sense the position of a rotating disc with precision. The resolution can go up to thousands of pulses per revolution, providing detailed angular displacement data. Second will be noise immunity. It is basically optical encoders are less susceptible to electrical noise and environmental interferences, ensuring accurate readings even in challenging conditions. Third is durability. Since optical encoders have fewer moving parts and non-contact sensing elements, they tend to have a longer lifespan and higher reliability. The last one, it will be speed. They can operate at high speeds, which is beneficial for application requiring rapid adjustments. Now let me explain you guys about the advantages of optical encoders. First, precision. Optical rotary encoders are highly precise due to their ability to achieve high resolutions, often up to several thousand pulses per revolution. This allows extremely accurate measurements of angular position and rotary speed. Their design minimizes hysteresis, providing consistent and accurate reading without significant lag or error. The precise optical patterns and advanced optoelectronic sensors ensure minimal measurement errors, making them ideal for applications requiring high precision. Second, reliability. Optical rotary encoders are highly reliable due to their non-contact sensing mechanism, which minimizes mechanical wear and extends their lifespan. Their durable construction, often up with sealed versions to protect against dust and contaminants, ensure consistent performance in various conditions. This stable and repeatable performance over time make them a dependable choice for precise measurement and control applications. Third, versatility. Optical rotary encoders are versatile due to their application in wide range of industries including robotics, industrial automation, and medical devices. They come in various sizes and mounting options fitting diverse mechanical setups. Their digital output signals are easily integrated with modern control systems, and they can accurately measure both speed and direction, making them suitable for complex motion controls. When there's advantage, there must be a disadvantage. The disadvantage of optical encoders are complexity and cost. Generally, optical rotary encoders are more complex and expensive compared to other types of encoders, such as magnetic or mechanical encoders. The complexity and cost of optical rotary encoders stem from their advanced technology, need for precise alignment and calibration, and the high manufacturing standards required to achieve their high precision and resolution. These factors make optical encoders more expensive and complex to integrate compared to simpler versions of encoder types.
Next is working principle. There are three main things, which is LED as a light source, code disc, which is a rotating disc with alternating transparent and opaque section, and the last one is photodetectors, sensors that detect light passing through the transparent section. Before getting into how the transducer works, let me show the circuit that we created from Tinkercad. This is the design that we created using Tinkercad, and I will tell you the components that we used. So the first one is we use Arduino Uno R3, this blue one here. Second one is breadboard small, this white board, this small board here. And the components are, other components are LED, resistor, these two resistors here, and one is photodiode, which is we use as a photodetectors. So now I'm going to tell you how to build this circuit. First, we drag these two main things, which is Arduino Uno 3 and breadboard small, to the workspace. Then we drag the small components to the workspace. The first component that we drag is LED. Connect the anode positive to a resistor, then to a digital pin on the Arduino, which is we connect the Arduinos to pin 2. Then connect the cathode negative to the ground force here. Then we add the photodiode on the breadboard, connect the one side to a resistor that goes to VCC5B here, this green wire. Then connect one side to a resistor and also connect this junction to analog input pin on the Arduino. Connect the other side of the photoresistor to ground force, this yellow wire here. Since Tinkercad does not have a direct way to create moving parts, we can simulate this by programming the Arduino to turn the LED on and off, mimicking the disc loads passing through the light path. Then we can write the code here. This is the code that we generate to make this circuit work. And after we done this coding, we can check whether this circuit is working or not by start the simulation. The USB will be plugged in, and if you see here, the LED will start to light up on and off. Let me zoom in. Right, we can see that the LED is blinking. We set both of the resistor to 10 kilo ohm to limit the current for the LED and the photodiode. By using a photodiode, we create a more accurate representation of an optical encoder in Tinkercad. The LED simulates the light source while the photodiode detects the light pulses simulating the slots in the rotating disc. We also can adjust the delays in the code to simulate different rotation speeds. This setup closely mimics how real optical encoders work, providing a practical educational experience.